All right, moving on. Our second lesson for factoring polynomials. Again, all we're doing is breaking it down into the original pieces that were multiplied together to make our polynomials. So we're kind of like dividing. The second lesson we have here is the grouping method. We're going to look at if we had 4 terms. This is going to be a helpful method that we can use in the future. So it's good to go ahead and talk about if there are 4 terms. I know I'm throwing you into the deep end. We went from like 2 terms to 4 terms, but this is really straightforward. The grouping method actually gets its name because we are going to use grouping symbols to help us factor. So our steps are group the first half or the first 2 terms together. We're going to put parentheses around the first 2, and then we're going to put parentheses around the second half or the second 2 terms. Put parentheses, first half and second half. Step 2, we're going to factor out a GCF from each of those groups. So just using our last lesson, out of the first half, find a GCF. Second half, find a GCF. And then the third step here is we're going to pull it together to make our final answer. So let me show you in action. I said our first step was we were going to put parentheses around the first 2 and parentheses around the last 2. So literally grouping method. Step 2, find a GCF from each of those groups and remove it. So our first set of parentheses, we've got x cubed and then 8x squared. So what can we remove? Number-wise, we've got an understood 1 and an 8. There's nothing I can remove there GCF-wise, but I do have x's in common. There's 3 x's in the first term and 2 in the last, so the most you can remove from both equally is 2, okay? So our GCF of our first group is going to be x squared. Second set of parentheses, we've got a 6 and a 48. So let's talk numbers. Does 6 divide into 48? Absolutely. So let's use all of that. GCF of this second set, we can use a 6, nothing else, okay? Because they don't share an x in common, so I can't also use an x, right? Okay, so we found a GCF from each group. Let me write it, factor it out. So let's pull out that x squared from our first group. When I remove an x squared from this x cubed, I'll have x left over, right? I took 2 out, there's 1 left over. When I take x squared out of my second term, I'm going to have 8. Moving on, we're going to do factor the GCF out of the second group. Take the 6 out, and we've got an x left over plus 8. All right. This says that you should get the same thing in the parentheses when you factor. Do you see that? We got an x plus 8 and an x plus 8. This is a clue that you are on the right track. If ever you work through this process of grouping and in your parentheses it's not the same thing, that's a clue that you've messed up along the way. So always look for your parentheses to match. And now we're going to pull our answer together. Take your GCF of x squared and 6 and make that a binomial. And then the parentheses that we saw match, the x plus 8 and the x plus 8, write that just once. And you're factored. Done. Final answer. Let's check it. So how would we check this? We're going to multiply it all back together. So I'm going to use FOIL. I'm going to do first, x squared times x is x cubed. I'm going to do outer, x squared times 8 is 8x squared. Inner is going to give me a 6x, and last is going to give me a 48. Is that our original problem? Yes. I know, wild, huh? So here is your factored form. I'm putting it in a box. The x squared plus 6 times x plus 8 is factored form for number 1. Let's try number 2. X cubed plus 2x squared plus 3x plus 6. Grouping. Group the first 2, last 2 together. Look for a GCF of each group. First group, GCF, x squared. You want to take your greatest common factor. They only share x's in common. GCF of the second group, a 3x and a 6. Your GCF will be a 3. Okay, let's remove it. First group, when I remove the x squared, I'll have an x left over plus 2. Second group, when I remove the 3, what do I have left? An x plus 2. Look, my parentheses are matching. I got x plus 2 and x plus 2. That is a good sign. Tells me I'm on the right track. So final step, we just pull these GCFs together as a binomial. So x squared plus 3. And then where we saw our parentheses matching, write it once, x plus 2. Final answer, we can check. Always, always, always. When you're factoring, you can multiply it back through. So first, x squared times x is x cubed. First outer will give me a 2x squared. Inner gives me 3x. And last is going to give me 6. Is that our original problem? It is. So we did a great job. Let's look at number 3. Again, we have 4 terms. So I'm going to use the grouping method. Look for a GCF in each group. GCF of the first half. 4 and 7 don't have common factors. So let's focus on the x's. We can take at most 2 x's out or x squared. Second GCF, second group. Now notice they both are negative. So I'm going to go ahead and remove a negative. And then 12 and 21 have a common factor of 3. 3 times 4 is 12. 3 times 7 is 21. So I'm going to do negative 3 as my GCF. Let's show that factored out. Remove the x squared from the first group, gives me a 4x plus 7. You can also use the fact that your parentheses are going to match to help you find GCFs. So if you were ever stuck, you would know, hey, in my next parentheses, I need it to be a 4x plus 7. So as I remove that negative 3, that is what I'm going to get, 4x plus 7 because I removed the negative 3. Your final step, pull those GCFs out as a binomial together. So x squared minus 3 times 4x plus 7. Final answer, there's our factored form, and you can check it. If I multiply my first terms together, I get 4x cubed. Outer terms give me 7x squared. Inner gives me negative 12x. And last is going to give me negative 21. Check and make sure I got the same as our original problem. Absolutely. So final answer, done. Number 4, last one. Again, we have 4 terms. I'm going to use the grouping method, grouping the first half and second half together, looking for a GCF in each group. First group, GCF, x squared. GCF second group, GCF a second group. If you can't find one, you can always use a 1. Let me show how this is going to look. So removing that x squared from the first group, we will have an x minus 2. Now look at the parentheses I just made. X minus 2, and then the second half of our polynomial was x minus 2. So again, this can be a clue of, hey, what should my GCF be? So if we use a GCF of a 1, then my parentheses are obviously not going to change. But now my parentheses match x minus 2, x minus 2. So I am factoring correctly. Bring this together. GCF's x squared plus 1, make a binomial, and then x minus 2. There's your final factored form. Let's check it. I'm going to use FOIL first. Gives me x cubed. Outer, negative 2x squared. Inner, x, and last, negative 2. Do we get it back? We got it back. So sometimes you need to use a GCF of a 1. And I know that seems weird sometimes, but that helps us get it factored down. So don't be alarmed. When you can't find a GCF, you can always use a 1, especially when you're using grouping like this. So there's our second lesson on factoring polynomials using that grouping method. It is for 4 terms, but we are getting ready to use it next. When we have 3 terms, we can manipulate our polynomials so we can use grouping. It's a very easy and quick method, especially when you're comfortable with finding GCFs. You know your multiplication tables really well. Practice those, guys. Remember, you can always check by foiling or multiplying your binomials back together to see if you get the original polynomial back. So this is a great opportunity when you're thinking about quizzing and taking your tests. You can check all of your answers before you submit them. So let me know if you have questions, guys, and good luck, and I'll see you in class.